Hello everyone, welcome to introductory course on the optimization. In this video, we'll build upon some complexity from the last video. But for the people who have not watched the earlier video, I'll explain the problem statement and then we'll go through the entire exercise. So what we have here is a manufacturer who produces four products, item A, B, C, and D. It has two manufacturing locations, MFG1 and MFG2. For each of the, what we want to achieve is that we want to find out how much to produce for each of these products at the two manufacturing location at the minimum cost. Now, what we have is minimum capacity for each item and manufacturing location. And in this case, the minimum capacity that we have is the conditional constraint. What it means is that the minimum capacity would be only applicable if that item has to be produced or is produced in that manufacturing location. We have the maximum capacity for each item and manufacturing location. We also have the variable cost, which is dollar per unit, and we have the fixed production cost, which is only one time. It does not matter how much you are producing, but it matters if you are producing in that manufacturing location and that item. So to summarize, we have the three constraints. The first is the minimum capacity, which is a conditional constraint. Second is the maximum capacity, you can also say, which is a conditional constraint. The third is the meeting the demand. We have two cost term in the objective, the variable production cost and the fixed production cost. In terms of the data, we have the demand at the item level in terms of the unit for each of these items. So let's start building the model. So what we will do is we'll introduce a production quantity variable. And I'll highlight these cells with different colors so you know which one are the variables and which one are the input data. We'll also introduce a binary variable in this case. So I'll name it binary var, which would represent if we are producing that item at a manufacturing location or not. So this is an binary variable. Now we need to implement the calculate the cost, which is the currently we have the two cost coefficient. So the variable production cost would be the sum product of how much we are producing multiplied with the variable production cost, which is dollar per unit. That becomes the variable production cost. Now let's also calculate the fixed production cost, fixed cost, which would be sum product of fixed production cost multiplied with the binary variable, which is this cell. So this binary variable again, they represent either yes or no, which would represent if it is 1, that means this item is being produced at this location. If it is 0, which means this item is not being produced at this location, right? So now we want to apply the minimum capacity and the maximum capacity constraint as a conditional constraint. So let's write the minimum capacity constraint as a conditional constraint. What we will do is we will say the production quantity would be greater than equals to the minimum capacity multiplied with the binary variable. Why are we multiplying the minimum capacity with the binary variable? Because we only want to apply the minimum capacity constraint if the model decide to use that manufacturing location for that product. So the minimum capacity becomes 120, which is this cell E multiplied with the binary variable. Now we'll drag this so that it is applicable for all the item manufacturing location. Then let's also apply the max capacity constraint. We will also multiply this binary variable multiplied with the maximum capacity per unit. Now let's do this. So we have the fixed cost, variable cost. So let's here write the total cost. The total cost is the variable production cost plus fixed cost. That would become the objective. So let me highlight this with a different cell. So this becomes the objective functions. Correct? And these two are our subcomponent of the objective function. Now let's write the demand constraint. So in this case, there might be the cases that sometimes the demand is higher than the overall the maximum capacity. In that case, we will not be able to fulfill the entire demand, but our model should be good enough to recommend, or good enough to recommend whatever the feasible solution is. So if the demand is higher than the maximum capacity, then it model might be the infeasible. If the demand is less than the minimum capacity, the model could be the infeasible as well. So what we will do is we will introduce a slack variable here. I explained the concept of the slack variable in my last video, so feel free to go and check that out. So this is a slack variable. Now what we will do is, what's the total supply? The supply is how much we are producing at item A at MFG1 plus MFG2. So this is MFG2, which would be this cell. Now we will also add the slack variable. So because we want to say that we want to produce at least up to the demand, and we could also produce more than the demand. If we are producing more than the demand, then that inventory would, then the excess production would sit in the inventory. So the constraint for us to fulfill the demand is the supply should be greater than equals to demand. So in cases when the supply, so what we are saying is that supply is greater than equals to demand. Now there could be cases that we are not able to supply. If demand is so high, then we are not able to fulfill the entire demand, and we just model this much, the model would be infeasible. So to remove that infeasibility and to get a optimal feasible solution, we will what we will do is we will introduce a slack variable, and this variable will only takes the value when it is necessary. Otherwise, this would be the zero. So the total supply becomes the production at MFG1 and the production at MFG2. I can drag this formula for all the cells so that it's correct for everything. Then we forgot to include the slack. Sorry, we forgot to include the slack variable. So here is the slack. I'll just again drag this formula. Now let's go to the solver and include all of the constraints, variable, and objective function in the model. So let's go to the data tab, the solver. Now here it says the set objective. So let's set the objective function. This cells contain the objective function for us, right? Then we want to minimize the total cost. So let me reset everything first, whatever I have here. So this is the objective function. We want to minimize the objective function by changing the variable cells. Which cells contain the variables, the decision variables. So these two, the I16 to J23 are the variable cells, comma. We also have these slack variables. So we'll include those. Then we need to include the constraint. So let's include the constraint. The first constraint for us is production should be greater than equals to minimum capacity constraint. Minimum capacity constraint. We'll click on the add. The next is the production quantity should be less than equals to maximum capacity. So here is the maximum capacity. Let's click on the add. The next constraint is the supply should be greater than equals to the demand. This is the demand. Click on the add. We also introduce the binary variable, and we need to tell the solver which cells contain the binary variable. So these cells are the binary variable. We'll click on the bin, and this would make sure that these cells are the binary variable. We'll click on the OK. We'll select the simplex LP and then we will solve it. Now you see the solution solver has found a feasible solution. And if you look at the solution, it did not produce anything here. The reason being it did not produce anything because we have a slack variable which took the all the values, because we did not include the slack variable in the objective function here. So what we need to do is we also need to include the slack in the objective term, because this variable should only take the value when it is necessary and when we do not have sufficient capacity. So to penalize this, what we will do is we will the objective coefficient for this slack penalty would be higher than all other objective terms in our model. So we'll take the max of the variable production cost, fixed production cost. We will take +1 to make sure that it is higher than all other objective coefficient. And then we will multiply this with the slack variable, which is the sum of this. Now let's include this objective term in the slack variable in the total objective terms. So this becomes the total objective function. And now let's go back to the data. Let's click on the solver. Let's again solve it. Now you see the solver has found a feasible solution. It says solver found a solution, all constraint and optimality conditions are satisfied. So let's click on the OK and let's look at the solution. So you see here, it's not using the the manufacturing location 2 for item B, and item B demand can be fulfilled using the just manufacturing location 1. So the max capacity is 300. It's producing the 300 at MFG 1 and 300 is the demand. For item 1, the total demand is 500, but the maximum capacity is 180, and at 2 it's 300. So the total capacity for item A is 480, but the demand is 500, so it could not fulfill the 20 demand and able to only produce 180 plus 300, which is the 480. So this becomes the variable cost, this becomes the fixed cost, and here we have the slack, which means this much demand we would be missing, and this is the recommended production quantity. And if you look at the minimum capacity, maximum capacity constraint, they are also satisfied. So this is how you include the conditional constraint. And to make the model feasible, how you include the slack variable and include that slack penalty in the objective term to make sure the model cover the entire or all the business cases. So let's say now let's take another data scenario where the maximum capacity is minimum capacity plus 100. Now if we do that, and we don't have to change any of the constraints, variables or anything, we can simply remove these, because these are decision variable. Even if you don't remove, the model will find the other values. So now let's go back to the solver and click on the solve, and we have a new solution based on the new data. Now you see for the item C, here it did not use the MFZ1 location, and as usual for item B, it did not use the MFZ2. And you see we do not have any missed demand here. Now we have the enough capacity for the item A, so it's producing and fulfilling the entire demand for item A as well. So this model is covering all the data scenarios and will make sure that it's not infeasible whatever be the data, and the minimum capacity and the maximum capacity constraints are also conditional constraint, which means the minimum capacity constraint only applicable if it is producing. In this case, the item C is not produced as at MFG1, so it did not apply the minimum capacity constraint. So that was about how you apply the conditional constraint. Make sure your model covering all the data scenario. So yeah, thank you. And if you like the video, if the video was helpful to you, please subscribe the channel.